right, so in E2 notes, we're moving on to rectangle properties. Okay, so remember our hierarchy picture that we keep going back and looking at. So we know we're in quadrilaterals, which are four-sided shapes. The first thing we talked about are parallelograms. And then a rectangle is a specific type of parallelogram. That means you should know the first 6 properties that we went through, okay, that make this a parallelogram. And then we'll talk about the specific parts that make it a rectangle. Okay, so here we go. First thing you should know, and we'll try to keep doing them in order so that you get a little bit faster at them, right? Part of that repetition and trying to help you get them memorized. We know in a parallelogram, you have 2 sets of parallel sides. And remember, parallel is shown with arrows. So we did some single arrows and some double arrows, and that's all arrows mean is parallel. Okay, what do you know about opposite sides? Well, opposite sides are equal, and this is how I'm allowing you guys to abbreviate them kind of quickly. So don't go too much less than this. So we'll go ahead and mark that in the picture, right? So we can have the same markings there and there, and I'll just put double markings on those 2. That means they're equal. We should know something about opposite angles. Opposite angles are equal. Okay, I'm not going to mark that, okay, because it just makes the picture too complicated. But opposite means across from, so we're talking angle A equals angle C, and angle D equals angle B. All right, what else do we know about angles? Remember, they're called consecutive angles. So the angles next to each other, okay, sorry, I didn't mean to write equals, but the consecutive angles are supplementary, right? Meaning they add up to 180. So like A and B are consecutive angles, B and C are consecutive angles, so on and so forth. Remember, one diagonal, this isn't truly like a property. This is just something I like to put in there for review. But when you draw in one diagonal, okay, as I like to show you as we're going along. So if I just draw in one diagonal from D to B, remember it creates 2 congruent triangles. Okay, since that's part of our study, and we would be able to look at what they were congruent by, right? And then likewise, the diagonals bisect each other. Okay, diagonals bisect each other is the last property that we had for parallelograms. So we'll go ahead and put in that other diagonal. And what that means to you is that from A to the middle, where they cross, equals from the middle to C, and from D to the middle and the middle to B. Okay, again, I'm not going to mark them because this is going to get more complicated quickly, the picture. All right, so these 6 things, right, are what make this a parallelogram, if you will, and I'm just abbreviating that. Okay, now you have to have something more specific about this picture to turn it into a rectangle. Okay, so I'm going to change colors if you're a color kind of person, and I will tell you that you're going to need one more line. Okay, I think you guys might already have it in your notes, but I will go ahead and add it for myself. Okay, so more specifically, you know what the angles are in a rectangle. What's in all of the corners? Look at the corner of the room. Right, they are right angles. Okay, so more specifically, we said opposite angles are equal. Well, yeah, A and C are equal. They're both 90. So are D and B. They're both 90. Notice that that still goes with our properties. Consecutive angles are supplementary, right? Like A and D are consecutive angles. 90 plus 90 is 180. Those are supplementary. Okay, and the other thing that's more specific is that the diagonals don't only bisect each other, but they now more specifically, they are equal in length. These 2 properties added are what turn this parallelogram into a more specific shape called a rectangle. Okay, so now let's look up here at the picture again. If the diagonals cut each other in half, right, they bisect each other and they're equal, well then, originally we would have said this part and this part were equal, and this part and this part were equal. But now that they cut each other in half and they're equal in length, all four of those parts are equal. Okay, so that's very much more specific for a rectangle. Again, we're coming down to the picture. Easy to make the assumption since we're on these notes. But you can't make any assumptions, guys, when you see a picture. Somebody either has to give you enough information marked in the picture for you to know that these are rectangles, okay, like right angles and enough information, or somebody has to flat out tell you they are. Okay, so keep that in mind for this chapter. All right, so I am flat out telling you that these are pictures of rectangles. Okay, so in these rectangles, let's solve for a few things. All right, so for this one, this first picture, write in for yourself. Let's find angle D, X, and BC, okay, with the information I'm giving you. So I'm going to start with X plus 1. I'll just circle that. That's my information that I'm giving you. X plus 3. And 2x minus 8 there. I think that's everything we need. Okay. All right, let's get us a little more room. And remember, we're going to keep practicing by writing down the properties that we're using. So, here we go. Angle D. I can answer that very quickly. You should be able to tell me angle D equals how many degrees? 90 degrees. Okay. Property used, you should be telling me right angles. Okay. Again, the more you can write these, whether ask for them or not, the better you will be at getting them memorized. Okay, we're supposed to find x. So what's an equation I could set up to solve for x? Well, I'm seeing that 2x minus 8 would equal x plus 3. And that reason would be opposite sides are equal. Okay, so quickly solve. If I subtract x from both sides, I'll have x. If I add 8 to both sides, I'd have 11. Okay, there's the solving for x, so I'll box that. And then I'm supposed to find BC. So again, notice BC is not labeled. But I can show my work. I can say, hey, I know that BC equals AD. And do some plug and chug. If I plug in 11 for x, I'd have 11 plus 1. And therefore, BC would equal 12. And again, what's the property that I used? I used the fact that opposite sides are equal. Okay? All right, next one. Let's go to the right. Let's ask you to find dB given this information. Let's put 12 and 5 there. So again, I'm circling the information I'm giving you. And I think that's it. Okay, that's all I want to give you. All right, well, when you see dB, guys, I hope you see dB as that diagonal. Well, I don't care if you call it dB or you call it x for a moment, okay? But here's what you got to recognize in a rectangle, okay, is one, you need to notice that you can put in the right angle here. And your focus should be in on this right triangle. Told you triangles were coming back. Okay, told you they were not leaving. Well, if you're looking at that right triangle right there, guys, well, you still know all of your old stuff, right? 30, 60, 90, 45, 45, 90, reducing triples, Pythagorean theorem. All right, sorry, I got interrupted. So I think I was just saying, don't forget all of your old stuff, guys, like reducing triples, Pythagorean theorem. When I see this in a right triangle, and I don't care if you call it dB or x again, I'm seeing that 5 and 12 don't reduce, but I know that's a triple, right? That's my shortcut. And I know my triple is 5, 12, 13. So when you're really writing the final answer, remember it's not X. That was up to you. That was what you put in the picture. But go ahead. So I'm going to go ahead and get rid of it now. But if you were doing a calculation and wanted to put it in like Pythagorean theorem, I'd probably use an X. But at the end, tell me dB, because that's what we're asking you for. dB is 13. I didn't reduce by anything, so that's my final answer. I'm done. Okay? All right, and then this last picture on the lower left, guys, let's ask you, I'll change colors so things don't get mixed up too much. Let's give a letter here. So let's put an O in the middle. Remember, when we give you a letter is a point, right? Capital letters are points. So know that we're talking about it's right there. We don't write it on top, though, because you got to be able to read it. So it's that point where diagonal BD and diagonal AC meet. And then if I put a 3 here, because a lot of this is just about knowing what the heck we're labeling. If I put a 3 there, you need to understand that I'm labeling the length from A to O. Okay? And then I'm asking you for the length of dB. Okay? So if that's the information and I ask you for the length of dB, think about that for a minute. Okay, I claim you should get 6. Now you need to give me the property or properties of why that is true. So 1, the diagonals bisect each other. Okay, but that's not enough. That just tells me that AO equals OC and DO equals OB. But how would I know that DB equals 6 when it's really AO that's labeled? All right, well, I know AC equals 6 and that DB would also equal 6 because you've got this other property. So we'll say diagonals bisect each other and the diagonals are equal in length. Okay, that's what sets that apart. Makes that into a rectangle instead of just a parallelogram. Okay? All right, so keep doing a good job of getting those characteristics and properties memorized so you know which one goes with which shape.